The transaction pool handles collecting transactions from multiple users. Primarily, it adds transactions one at a time. However, the pool also handles replacing transactions if they receive an updated one with the same ID. This is why the primary function in the transaction pool class is called update or add. Let's test both of these use cases in a file called transaction-pool.test.js alongside the existing transaction pool.js file. So we'll make a new file, transaction-pool.test.js. At the top of this file, let's get access to the transaction pool class. So we'll make a transaction pool constant that is the result of requiring the transaction pool class we just created. We'll also want access to the transaction class since we'll be using some of the methods within there to create transactions. So let's require the local transaction file. And finally, we'll also want the wallet class so that way we can make some transactions with a wallet. So let's make the wallet class by requiring the local index file. We'll capture all of the tests by describing the transaction pool. So here we have our describe block for the transaction pool, which has our familiar callback arrow function. For each following test, we'll have variables for a transaction pool instance, which we'll shorten by calling TP. We'll have a wallet instance, and then we'll also have a transaction instance that we can test on. Before each test now, we'll set the TP variable to a new instance of the transaction pool. So here we have our before each block. And then before each following test, we'll make this TP instance a new transaction pool. The transaction pool variable will be created with the new transaction function. But first, we'll also want to create a new wallet. So let's make a new wallet and set that to the wallet variable. Now the new transaction function has the wallet argument, as well as an arbitrary recipient address and amount. So let's set the transaction to the transaction.newTransaction function. And then we'll pass in the wallet we just created, which is the first parameter. And then we can have a random address. So how about R4ND-4DR355, which just looks like rand address in LeetSpeak if you try really hard and read those letters as numbers. And then we have an arbitrary amount as well. So how about 30? And then finally, we'll call tp.update or add transaction with this newly created transaction. So tp.update transaction, let's pass in this transaction that we just created. Excellent. Every following test will now have a transaction pool with the one transaction that we just created within its transactions array. For the first test, let's make sure that the transaction pool is added to begin with. We'll have a test to prove that the transaction pool adds transactions to the pool itself. So the test says it adds a transaction to the pool. And then here's our arrow callback function. To make sure that the transaction exists, we'll look through the transactions pool array and then find the transaction with the matching ID field to the static transaction we created in the before each block. And then we'll expect that this transaction is the same object as the originally created transaction. This should prove that the transaction itself was added to the pool. So we'll expect, first let's find the matching transaction within the transactions of the transaction pool. So that would be in tp.transactions. And then we'll use the find function to find a specific one. We'll look at transactions one transaction object at a time with a t variable. And then we'll return the one whose t.id is equal to the transaction.id of the one we created in the before each block. And then we'll expect this found transaction object to equal the original transaction that we just created. Great. Now let's test the next use case where a transaction gets updated in the pool. So we'll say it updates a transaction in the pool. And then here's the callback arrow function. The strategy for this one will be a little more involved. The goal will be to check if the transaction pool updates a transaction within its transactions array when it receives a transaction with an identical ID. First, we'll update the transaction, and then we'll pass that into the update or add function. And then we'll check if the transaction in the pool has the updated information. However, we want to check that the original transaction within the pool changed when we send the updated one to the pool. If we call update to our overall transaction object though, then we won't have a copy of what that original object looked like when we try to test if that change actually happened. So as a solution, we'll get a copy of what the original transaction looked like by creating an old transaction variable. So we'll have const old transaction, and that will be set to the stringified form of the transaction in its current state. So the old transaction is equal to json.stringify transaction. And now we can update the transaction with the wallet and arbitrary values. So let's make a new transaction variable that is equal to calling transaction.update, passing in the wallet. How about another address? So foo 4ddr355, and then the amount can be anything. So how about 40? And then we'll tell our transactions pool to update or add this new transaction. So tp.update or add transaction, new transaction. This allows us to assert and check that the transaction was updated in the pool. We'll find the transaction within the pool whose ID matches the overall transaction object's ID. And then we'll make sure its stringified form is not the same as this old transaction, which was an old copy of the transaction object before it was updated. So we'll expect that the, JSON.stringified form of the transaction we want to find, which just like above, we look through the transactions in the pool one at a time, one T object at a time, and we find the one whose ID matches this time the new transaction.id. And then we'll expect that the stringified form of this found object, which matches the new transaction's ID, we don't want it to equal the old transaction. So we say .not to equal the old transaction, which is a stringified form of the transaction before it was updated. So make sure you have this inner .not because you don't want them to equal each other. So this not specifically testifies to that. Great. With the add test and the update test prepared, let's make sure that they actually pass when we run the entire test suite on the command line. So go ahead and open up the command line, and then we'll run our test runner with npm run test. Perfect. If all goes well, it's going, and indeed all of the tests pass. All right, that covers proving that the transaction pool adds and updates transactions in the way that we expect it to. Moving on, we'll add a method to the wallet class that wraps up both creating transactions and adding them to the pool all at once. Then we'll soon move on to including this transaction pool within the peer-to-peer server so that we can get multiple users to use synchronized transaction pools and share all of their transactions across the network.